Thank you for that warm introduction. This is a really good-looking crowd. Wow. How's everyone doing? Enjoying Node.js in action. Yeah, like mentioned, my name is Yunong. I work at Netflix. Has anyone heard of us? No? Anyway, so we start with this simple idea, right, which is, we want you to be able to watch your favorite content sort of anywhere, anytime, whether that's dramas, comedies, or award-winning original series. And here's just a few selection of some of my favorites. I'm sure you've all got yours. But more recently, we've been making this push, too, for Netflix to be available, broadly speaking, everywhere in the world. I know we have a pretty diverse crowd up there, so I'm sure you guys can't complain after the time and be like, when's Netflix coming to my country? Because it's there now. But as we've sort of been expanding our reach to the rest of the world, we've also experienced some pretty stunning subscriber growth over the last few years. So we're now up to almost 85 million subscribers. And with this growth and our global expansion and our moving to originals content, we actually have a pretty unique set of scaling challenges here at Netflix. And so today I'm here to sort of walk you through our API evolution, right? How we've evolved our API along with our growth. And don't worry, monoliths and node and containers will show up along the way. So it's not a bait and switch title or anything like that. So you want to watch Netflix, right? How does everything work? Well, as most of you probably know, we're sort of the poster child for going to the cloud. We've long abandoned our own data centers for infrastructure hosted on top of AWS. And so once our engineers had ported all of our stuff into the cloud, we were done, right? We sat around all day and just watched TV shows. Turns out that's not the case. There is no cloud, as everyone's well aware of. It's just someone else's computer. But more than that, actually, just because we abstracted away the infrastructure, we still have to scale out the platforms and the services that run on top of that infrastructure today. And so let's talk about that, right? Our premise is, today we're known for letting you watch Netflix on any platform. And you pull out your phone, on your laptops, on your game consoles, even on the Nintendo Entertainment System. That was like a Hack Day project. But in the very beginning, it turns out, right, most of you probably don't remember this, maybe some of you do, the early hardcore subscribers, we were only available on the browsers. And so what did that architecture and API infrastructure look like? Well, we had a Java-based web server, and that web server did everything, right? It rendered the UI, so all the markup that gets sent back to the browser, it did all of that, but also did all of the data access. And we're known for this microservices-based architecture, so the mid-tier and the back end, every single team really owns their own independent microservice, and they provide a client for the Java web server to use. So there's a ton of coordination here, right? And this is sort of our first evolution. It was responsible for doing everything, like I said before. So let's play a game called Spot the Monolith, right? Can anyone spot the monolith? It's pretty obvious here, right? This is the monolith. And so what were some of the issues? Some of these are pretty obvious. I think the biggest thing is it was really, really slow to push and to innovate. Because imagine, hey, a new show just launched, say The Crown, which is one of our really amazing new original series, and I want to add a new original role title to the UI, right? That means I have to push this web service. What if I want one of the backend teams says, hey, I have a client update that has a security vulnerability or a performance fix I want you to integrate. Again, I have to push the service. Maybe I want to add a new microservice from the stack, I have to push the service. So basically, anytime you make any changes up and down the entire Netflix stack, you have to push this service. And because it was complicated and encapsulated sort of all of this different functionality, it was painful and a painful exercise to do every time. And at the same time, we wanted to move beyond just browsers, right? We wanted to add a bunch of all the other devices in the ecosystem. So how could we move from this sort of monolithic API, this monolithic infrastructure to something that would support multiple devices? Well, let's take a look at the next journey in our API evolution, right? So we start with this Java-based web server, which is a monolith, and we moved, in order to support multiple clients, to what everyone else does, right? Which is the REST API. And this is the industry standard. We exposed the REST API, and this really unlocked the ability for us to support more than one device, right? So we could support now, a TV and the iOS and Androids of the world. And it broke apart the monolith. And what's really critical here is that we're no longer rendering the UI and accessing data in the same process. And this is good. But what are some of the unfortunate aspects of having to use the REST API? Well, the REST API, as it turns out, was initially designed for just one device, right? This meant that as we brought more and more devices online, you can imagine every single device has a different experience. They may want a different data access API, so it was inflexible, right? Often, because a different team owned the REST API, the client teams were backed up waiting weeks for that team to make changes to the REST API. It was also inefficient, being that it's REST and it's resource-based. You can imagine every little element on the Netflix UI is a resource. So in order to like fetch an entire page of all your movies, that's multiple round trips to the back end, to the data center to be able to fetch and grab all those assets back. And as time had elapsed, the API continued to acquire some bloat, and we were retrofitting it with lots of different unique APIs for different clients. It became hard to maintain. There was really this tug of war now between all the client teams who really wanted bespoke APIs for their own user experience, but had to wrestle with a single REST API. So what do we do, right? What does the next sort of step in our API evolution look like? Well, I thought I'd take a step and sort of talk about our ethos at Netflix, which is really the design for innovation. I mean, one of the places where we really differentiate ourselves, in addition to the amazing content and the great algorithms, is our innovative UIs, right? So things that we're sort of optimizing for from an engineering perspective is rapid innovation, right? We want even more A/B tests to be able to just holistically test the user experience. We want to make sure that we're available on every single device that's out there. Performance really matters, right? The faster you're able to load that stuff, the easier it is for you to consume the content and for our customers to enjoy the great content. So what this really meant is these teams really wanted to customize the API, right? They wanted to be able to change that REST API on the fly whenever they like to support new features or new A/B tests that's specifically crafted for their own clients, and they wouldn't have to share with any other clients, right? Because you're the web team and you want a specific API, and maybe the TV team wants something completely different because the UI looks different, right? And the interactions are different. So we wanted to be able to write these tailor-made APIs. And the existing REST API didn't really scale, right? It was inflexible, again, multiple requests and round trips to load a page, and we want to be able to move from one API to custom APIs that teams can craft themselves and be able to change. So what did the next version of our API infrastructure look like? Well, we named it API.next, and it was something like this, right? So we have this API server that's owned by our edge services team, and instead of have one rigid, strict REST API, we now let these teams upload their own custom APIs to the service. So you can upload any number of these custom APIs that you craft in a Groovy script, and these scripts are unique and sort of specific for yourself. So you can change them however you like. So Team A can change 50 different versions of their scripts without affecting Team B. And they're integrating these little data access APIs against the Netflix backend with the client's libraries that Edge Services provides. So there's no more new deployments that's needed. Whenever you need to upgrade your APIs or change your APIs or add new APIs, you just simply upload them to the API.next service. And the API server itself can be updated independently of all of these different APIs that you're writing. And this was infrastructureless as well. So these client teams now get the flexibility of authoring their own APIs without having to run it in the infrastructure. But let's play that game again, which is spot the monolith, right? Where's the monolith this time? It's there, right? It's still back there. And that's because and we're actually running into some scaling problems now with this monolithic process. So this is the actual API infrastructure that's available today that's running all of Netflix. And let's take a moment and talk about some of the scaling challenges that we have, right? We had about 43 billion hours that was watched in 2015, and then we have billions of RPS per day through the system. And so we have thousands of these custom API scripts active in prod at any one time, even more in test, tens of thousands. And all of these go through hundreds of changes a day, and we have hundreds of A/B tests with lots of variants per test. So there's a lot of scale happening within this one single monolithic system. And because all these scripts live inside one process, there are some scaling issues, right? We're quickly running into some vertical scaling issues. You can imagine all of these scripts have to live inside one process. So we're running out of headroom, whether that's memory, CPU, or I/O, right? And there's a cost associated to this as well, right? Because each of these really, really large instances are really expensive. And in addition to that, all these scripts living together inside one process isn't the best scenario, right? We've had some outages in the past due to the fact that one script had a memory leak or had a problem, and that ended up taking down the entire process, which meant that every single client was unavailable, right? Just because, say, I'm just picking, the TV UI team pushed a bad build of their own data access APIs, ended up taking down the entire Netflix stack. So one bad script can take out everyone, that's not good, right? And there's also, in Java, conflicting dependencies. Everyone has to, the 10 or 15 teams that use this system have to agree on all the different dependencies, right? So they have to agree on the same version of Log4j, for example, and the same version of the HTTP clients and all of that. So this is not ideal. Additionally, developer ergonomics wasn't that great either because there's this natural separation down the middle, right? On the left is everything that a UI engineering team would own, which is both the client code, which 90% of our clients are written in JavaScript, and then the data access APIs, which they're writing in GroovyScript, which people have heard of Groovy, I hope, right? At least couple hands. But it's not ideal. And then on the right-hand side of the big box is where everything that systems engineering owns, right? All the back-end sort of traditional, service ownership, service teams that you would imagine. And deploying this monolithic process takes hours, right? And so it's a huge monolithic process. You can't run this stuff locally. So for engineers who are writing these data access APIs, instead of being able to run and debug everything locally, they actually have to upload these scripts to a set of test instances, right? And then hit them with curl or whatever to see if they work. And if they don't work, add print line statements and repeat the process. It's very, very painful, and it slows down our innovation, which is something we talked about, right? So with all these things in mind, what have we learned from all these previous incantations, right? And let's talk about sort of what our future sort of facing APIs will look like, right? How do we get more and more devices and get faster velocity of change? So what would our goals be to create the next generation of API platform, right? And I think it comes down to three things, which is scalability, availability, and developer productivity. And we'll go through these in detail. So let's talk about scalability and availability, right? The biggest thing here is process isolation because, again, we don't want to take an outage because one data access script has blown up. So we want to be able to horizontally isolate all of these data access scripts from each other. This also helps us reduce infrastructure costs. You can imagine that if I have a data access script that's taking 10 RPS, another one that's taking 1,000 RPS, they shouldn't really share the same process space, right? Because one should use drastically less number of resources than the other. We also want faster startup times, right? And we want an immutable deployment artifact so that we can easily reproduce the different builds that we have that's available. What about developer productivity, right? We often don't really think about this, but this is actually one of the really important asks from all of our engineering teams, which is that, one, they want to code in JavaScript on the server and on the client, right? Nobody wants to write Groovy scripts. But even more important than that, they never ever want to have to wait like 10 minutes between turnarounds of debugging their scripts. They want to be able to run and debug everything locally, set breakpoints. They want fast incremental builds, and they want an environment that as closely mirrors production as possible, right? And remember that with API.next, because it was so huge, we had to actually upload the code to the remote server instead of debugging everything locally, which was very painful. So let's look at the API evolution, right? So we start with the monolithic API.next server, where you upload your data access scripts and everything lives together. And we talked about the fact that there's this natural separation right down the middle, right? Where we have these data access APIs on one side and a service that integrates against the backend services on the other side. So what could the next generation data access API look like? Well, it'll look like something like this, right? We've taken all those data access APIs and moved them out into their separate apps. And they're now running Node.js, which is great. And these scripts that used to be Groovy are now running Node, and they're also horizontally isolated and running inside of a Docker container. And we'll get into the details of that platforming a little bit in the next couple of slides. And we also migrated the other side of that old platform into something we're calling the remote service layer. So that's still Java-based, and it's still doing all the integration and the heavy lifting that integrates against the backend services, but it's just one consistent API. And whenever our developers on the front end want to craft new APIs, they simply just have to push new JavaScript on the server in the form of a Node.js container. So this talk, we're going to focus more on the front end part because we're at a Node conference, so we're going to talk about the Node API platform itself. So what is that, right? The Node API platform is literally a set of JavaScript data access scripts that's running Node, and the HTTP framework we use at Netflix is called restify, and it's all running inside of a Docker container. So if you remember those Groovy scripts that were being injected into the single monolith, now they're injected into their own isolated Docker containers, right? And that's really powerful because that means that we're getting that horizontal isolation and a bunch of the other goals that we talked about, and we'll walk through that in the next few slides. So how do we go from that design on paper to a new API running in the cloud at our scale, right? We have to invest in a bunch of things. So the things that we've been investing in is the runtime platform, application management, which is how do we manage now these potentially hundreds of these different API applications that's owned by UI engineering teams. What about the container infrastructure? Because we've traditionally only run on VMs at Netflix. So how do we manage this new sort of paradigm shifting, deploying infrastructure. And what about developer tools, right? We've had some developer productivity gains that we wanted to hit as well. So let's talk about the runtime platform. I was trying to write this slide, this talk, and I came upon this kind of funny quote on Twitter, which was that a full stack developer is one who can add technical debt to any layer of the application. Right, and you know, this is kind of joking, but there's some truth in this. And the truth in this isn't really, it's more like, hey, we've hired these really great world-class UI engineers, right? Why would we have them go run servers, right? It doesn't really make sense, right? That's not where their expertise is, their passion is, right? So they don't care about that. We want them to do what they're good at, which is writing really awesome reactive user interfaces. So our aim here was to provide a paved path for these data access apps, right? We have a great set of subsystems on Netflix that lets you run reliably and availably any services at scale, right? And our job is to provide a platform on Node that provides integration, full integration with all the Netflix subsystems. So that's things like metrics, alerts, you know, auto scaling, load balancing, service discovery, analytics, all this stuff that, you know, we already have at Netflix. We just want to be able to provide this for free to any engineers who are writing a Node-based data access API, right? Again, we've hired some really great UI engineers, so you know, let's have them do what they're great at, right? If you ask me to write UIs, it'd probably just be tables. So I mean, you know, you gotta make sure that you're investing in the right places. So what is the Node runtime, right? Well, the Node runtime, we've provided a platform as a service model. So again, we're maintaining the same contract that these UI engineers had before with the API.next infrastructure, which is that they don't own any of the infrastructure, right? And so we're providing a production-ready Node platform. And all they have to bring is just functional JavaScript business logic. So they're implementing like a middleware express type, restify type handler, and they're just building that into their application, and everything else is free, right? All the sort of integrations with the Netflix ecosystem, service discovery, metrics, logging, analytics, all that stuff, alerting, all that stuff you just get for free. Of course, we give you the flexibility if you want to sort of peel that back and play around and make changes to that. But ideally, you know, when you just bootstrap a new application like this, everything already just exists, right? Again, our focus here is for it to be infrastructureless, for these UI engineers to not have to worry about running infrastructures at scale, but to craft really great, unique experiences for our customers. So what about application management, right? Here, again, this is something completely new to the stack, because now we're taking one monolith and breaking it apart into multiple discrete applications. There's three things that we're thinking about, which is versioning, deployment, and operational insights, right? So in terms of versioning, you have to realize that these APIs, they change all the time, right? So there's literally hundreds and thousands of different versions, because you can make changes to these APIs anytime you like. In the past, we have sort of an inconsistent versioning issue, which is like every team just came up with their own sort of versioning schemes. Like TV would use a timestamp, and maybe web uses a GIF shot. Some other team would use an integer. And this is wildly inconsistent and really hard to manage. And so our goal here was to get consistent versions of reproducible builds. Is there something from the Node ecosystem that we could use to manage versions? Of course, right? We could just use Semver. So we decided actually, not only do we all use Semver for packages, we're actually now using Semver to manage all of our services as well. So we build sort of an NPM for services in Netflix called the Node API Index, and that actually immutably tracks all of the versions of all of your applications that you've published with the semantic versions. You can see the owner, the Git commit that it maps to, the Docker image that it builds. And so this ensures that every single version is trackable back to both an STM commit and a Docker image, which means that all of these bits are immutable. So that this really helps out with the reproducibility of your application. What about routing, right? Back in the old system, we would have to route based on the actual path of the API itself. Well, this was a problem, right? Because we have applications out there, or clients out there that are long-lived clients. And so these are baked into the apps themselves. And so let's say I've shipped an iOS client, and it's at version 1.3.2, and that's baked into my app. If there's a bug or something and I want to update the version of the server, right? Because we have immutable infrastructure, immutable deployment artifacts, I can't just override that. I have to ship a new version. I'll never be able to route back to 1.3.2. I have to route to 1.3.3. But what's baked in, with the path that's baked into the client is effectively pinned, right? Again, since we're using Semver really helps out here, right? Because instead of just shipping the pinned version, we could ship a Semver version with the carrot, which with our sort of routing infrastructure now lets you route based on these actual summary streams. Just like how NPM is resolving your dependencies and gives you the latest version of that, whatever thing that you're matching. In this case, it's the same thing, right? We're able to update the versions underneath the hood, and because we're floating, we're able to just resolve to the latest version of that application. And with operational insights, we built in this rich set of operational insights into the application that lets you list and view all your deployed apps and their routes, the deployment history, analytics, metrics. Good example of this is like our generated dashboards that you're able to get whenever you deploy an application. Again, like you as a UI engineer, for example, don't have to do any of this. All this stuff just shows up. What about the third section, which is container infrastructure, right? As you all know, this is sort of our first foray into containers. We built something called Titus, which is our own sort of homegrown container management and scheduling system. This is its own talk, so I'm not going to go too much into it, but if you're curious, go check it out. But it's an infrastructure with which we're able to reliably deploy and run containers in the cloud. And the last section is really on developer tools. And you recall our aim here is developer productivity, right? The biggest thing is, hey, I want to be able to develop and test and do everything locally. I never want to have to upload and wait to test my service. And the problem here is, even if we're using Docker, I'm able to drop these Docker containers locally onto my desktop. If I make changes and I build a new Docker image, that build all the Docker stuff and building the Docker dependencies and then ultimately the Docker image still takes tens of minutes, right? And so I got 4 slides left, so I'm almost done. So that's an issue, right? So how do we solve that problem? Well, we've created this really unique set of tooling that lets you rapidly develop locally. So what we've done is mapped your workspace from your local host into the Docker guest that's running locally. And whenever you make changes on your laptop, that gets mapped into a Docker container that's running inside of your development environment. And so these changes are reflected back and forth. And so they're basically automatically picked up inside the Docker container. We have tooling that rebuilds your dependencies or restarts the application whenever you make changes. So now we're back to sort of sub-seconds in terms of making changes, being able to develop, debug, and you can even attach debuggers to the application itself. So as a quick recap, right, the reason we went with containers is like they give you process isolation and a layered dependency management and portability across environments, right? So I can take a image that I deployed to prod and bring it down and test that. It gives me fast deployments and a single deployment artifact. And this lets me test my build artifacts anywhere in the cloud or locally even. And with Node, as you all know here, the reason we chose Node is we could use JavaScript everywhere, right? Client and the server. So it's really easy for engineers when they're writing their apps to both write JavaScript on the client and the server. It's performant, it's lightweight, there's a superb ecosystem in all the NPM modules, and it's built for the web. So as a recap, the 3 things that we're really focused on for the new Node platform. 1, developer productivity, right? Really lets you run, debug, and test things locally, fast incremental builds, and scalability and availability, right? Breaking that monolith into microservices running inside of a Docker container running Node with process isolation, so we're getting better availability. Everything's horizontally scalable, and we have immutable deployment artifacts. And so today I walked you guys through sort of our our journey in the Netflix API, and we've been recently running some tests with this new platform, and it's done really well. And in the new year, we hope to start deploying that to some of the clients that you'll see out in the Netflix ecosystem. So thanks so much for your time.